Sometimes you forget things that you've done in the past. Perfectly normal. So if you've forgotten how to do something, there's either option one where you say, oh, I forgot, so I should try nothing. It's not necessarily the best option, but it is an option that many people take. But if you've forgotten it, sometimes you can get an idea by just playing around with it. For example, x squared plus 9 has to be less than or equal to 25. Can someone tell me a number that works, and someone tell me a number that doesn't work? So let's get an answer for x that makes that true, and let's get an answer for x that makes it false. So 2, it's very good to start off by saying a random number, because you will be right. It will either work or not work, and you will have solved one of those questions. If we pick 2, if x is 2, is the answer less than or equal to 25? Yes. 2 works. 4 also works. Because the 16 plus 9 is 25, it equals. In fact, kind of ruined one of my later questions. Why are you looking at me? Because I was going to ask, what's the biggest number that would work? And you ruined that. So, just a little bit annoyed right now. But I'll get over it. What would be a number that doesn't work? 5. 5 is too big. We've already found out the biggest number that works. Is there a smallest number that works? Let's try some small numbers. 0 works. Is that the smallest number that works? Negative 4 works. Is that the smallest number that works? Does negative 5 work? Negative 5 doesn't work. Now we have to be sometimes careful, because just because negative 4 works and negative 5 doesn't work, it could be possible that negative 4.1 might work, but negative 4.1 doesn't. Negative 4 is the smallest one that works because that makes it equal to 25 again. So just by doing this a little bit, you'd probably come up with the solution. And the solution to this is that the answers for x are actually a bunch of them. They're going to be everything between negative 4 and 4. That's the solution. Okay? And we got that just by thinking about the answers, and it didn't take us too long. But now I'm going to review for you the process that you learned in grade 11 and see if it makes sense. In grade 11, what happened was that, here, I'll do it right beside, and then we can do the second one after. Hold on. But what you did in grade 11, you said, okay, first of all, let's find out where it equals 25. If it's equal to 25, then I can move the 9 over. And square rooting, I would get plus or minus 4. That was kind of our biggest value and our littlest value. In grade 11, we then made a number line and put those values on there, negative 4 and 4. And you had the option of either making open circles or circles that were filled in. We used open circles when the original equation was less than or greater than, but because this had an equal sign, we would have filled in the circles. And there's something really kind of enjoyable about coloring them. Perfect. Feel so good about that. Then on your number line, these were the places that it was equal. So now we have to test. In each of these sections will either always work or always not work. Will either be true or be false. Now, we did our test points already. We tested 5. 5 doesn't work. That tells us this whole section will be false. We tested negative 5. that whole section is false. We tested 2, and it worked. This whole section was true. This was the method we used in grade 11. Okay? And then from this, you could write your solution, because you now know the section that's true. It's between -4 and 4. So there's a little review of grade 11. Okay? And now that you see it again, the method should make sense based on how we sort of figured out the answers. The method is nice that way. You find out where it's equal, and then you check the sections. Graphically, we can think about this as well. If we take this, and I like to make one side equal to 0. So can you see that I could take this and subtract the 25 and make one side equal to 0? What does the graph of x squared minus 16 look like? It's a parabola that's been moved down 16 units. Would you agree this is your parabola? It has x-intercepts at -4 and 4. There's your number line. What part of the parabola are we looking for? We're looking for when is the parabola less than or equal to 0? There is where your parabola, the y values are less than or equal to 0. That's the section that ended up being true. So sort of connecting your graphical and algebraic solutions together. Kind of nice to see it that way. So I like to rearrange it so something has a 0, because then you can really see where y is bigger than your x-axis or less than your x-axis. For this one, it's going to look for where the parabola is bigger than 0 above your x-axis. So we'll do B together. B was x squared plus x minus 6. We start by making it equal to 0. This one you can factor. Plus 3 and minus 2, does that work? Is that good factoring? Good. So then you get x equals minus 3 and x equals 2. Those are your endpoints. And once you see the algebra way, it's a lot better than the guessing and checking that we did at first, because you could find numbers that would have worked for this one too. But finding the biggest and the smallest might have taken you a while of guessing and checking. The algebra, well, sometimes takes longer than guessing and checking, but on average, doing something algebraically saves you time, especially when the questions are hard. So now we can make our number line. And on our number line, we're going to have -3 and 2. And this time, they're open circles because it wasn't included. And test points. If you test 0, I like using 0 as my first test point. 0 plus 0 minus 6. Is minus 6 bigger than 0? No. This middle section will be false. Test something bigger. This section is true. This section is true. You might start to think, does it always alternate true, false, true? No, not necessarily. You'll get some in AP Calculus that go something similar to this that might go true, true, false. Or true, false, false. Or true, 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 all the way through. So there's sometimes different things that can happen. But with parabolas, like if you think about this graphically, this is a parabola. Which way does that parabola open? It opens up. Can you imagine in purple here a parabola with those x-intercepts opening up? And what is the question asking us? When was the parabola bigger than 0? Definitely true in this section. Definitely true in this section. So then we write our solution as -3 to 2 with open brackets in integral notation, where you just don't include the equal sign when solving that. Where does this come together for us? Well, sometimes we're going to do the composition of functions, with, oh, I wrote it wrong. Thank you for looking confused. This is where it's false. I'm sorry. Negative infinity to negative 3, and then it starts again from 2 to infinity. That's the true section. And we would write this as x less than negative 3, and you have to use the word or, x is bigger than 2. So I appreciate when you guys look dazed and confused, because it sometimes helps when I make a mistake up on the board. Okay. So how does this relate to what we're doing with the composition of functions? We're going to do this example together as well. Do they have this chart for you on the next page and everything? No, they do. So we have f of x being a square root graph, and g of x being x squared minus 1. And they want us to do f of g of x. So does it make sense that you would do the g of x first? G of x is whatever you put in, you square and minus 1. So this, negative 3 squared is 9 minus 1, that's 8. This will be 3. This will be 0. This one is negative 1. Oh, and squaring doesn't matter, so this will be 0, 3, and 8 again. Okay. Then, after you do g of x, whatever number you get there gets thrown into f of x. We've got one machine first, then the second machine after. So what happens when you throw 8 into f of x? You get, you see that you'd get the square root of negative 5? Boom. That is not possible. That would blow up that square root. Plugging in 3, though, is no problem. That's just going to be 0. Plugging in 0 would give me the square root of 3. Plugging in negative 1, 3 minus a negative, that'll be 4. Square root of 4 is 2. And these ones will be the same. And we'll end with a bang. That'll be not possible again. So according to this, if we were graphing f of g of x, if you plugged in minus 3, it blows up. If you plugged in negative 2, you get 0. If you plug in negative 1, you get the square root of 3. If you plug in 0, you get 2. If you plug in 1, you get the square root of 3. And if you plugged in 2, you get 0 again. See how I'm plugging in my original x and graphing my y. It looks like this is what I get. It looks like my domain goes from negative 2 to 2, and my range goes from 0 to 2. But I'm not complete, like I just did a table of values. Maybe I haven't got it completely right. I'm just assuming that's what it would be. So what we're going to do in this unit is we're going to figure out how to actually put this together and how to know for sure that that graph was right, and also review some of our other units, and it'll also explain why this skill from grade 11 is important. And this example is such a good one, we're going to actually do everything with this example. And with composition of functions, the explicit equation is really, really helpful. So if I wanted to do f of g of x, well, g of x is x squared minus 1. So this would be f of x squared minus 1. And then the f machine says whatever you put in, you square root it, and you minus, no, it's 3 minus whatever you put in, inside of a square root. 3 3 minus, and I would plug in x squared minus 1. If I simplify this, and you see that you would get square root, I'd have a negative x squared, I'm going to write that first, and 3 minus a negative 1 would be plus 4. Okay. The reason this is connected to grade 11 is because they're going to ask you, what's the domain of this? And what are you allowed to square root? You are allowed to figure out the domain. The inside, the negative x squared plus 4 has to be bigger than or equal to 0, because you're not allowed to square root negative numbers. I have an inequality from grade 11. How do I solve inequalities from grade 11? First of all, I find out where it's equal to 0. So 4 equals x squared, and x would be plus or minus 2. I draw my number line, minus 2 and 2. And since there's an equal sign, I can fill those circles in. And I check, where is it true, where is it false? If I plug in 0, this is true. If I plug in 3, this is false. If I plug in negative 3, this is false. And so my domain is that x has to be between negative 2 and 2. Okay? You could have also figured out your domain from the graph. So next thing we're going to do is we're going to look at chapter 2 and do a little review of how did you graph square roots of anything. So do you remember from chapter 2, when you wanted to graph the square root of any graph, the first thing you did was graph the inside. What is the inside? It's a parabola, flipped down, shifted up 4 units. 1, 2, 3, 4. It's going to have a maximum at 0, 4. I'm going to graph it in blue. It's going down. It has an x-intercept at 2 and at negative 2. Then in purple, if you knew the inside graph, a reminder from chapter 2, you can graph the square root of everything by first finding every place where the y value is 0 and the y value is 1. Then take any nice points that you can square root. Like, can I square root 4? Yes, I get 2. Between 0 and 1, your graph has to be slightly above. And then below. It's the same that we got, like my graph that I drew for my table of values, almost identical, but now that I've done it algebraically, I know that it's perfect. I know this is the correct graph. And from this, I could also say the domain goes from negative 2 to 2, and my range goes from 0 to 2. So it's kind of neat when units start to connect to each other, and ideas start to be like, oh, I can use ideas from one unit to help me in another unit. Okay, this is the main idea of this unit. How when you combine functions, you are going to find out that if you write the explicit equation when you combine them, you're going to be able to solve all sorts of questions easier than a table of values. You're going to be able to use your graphing skills. Not always will they have a square root. If they have a square root, you have to use this grade 11 concept. And almost always they'll only square root a parabola, so it's not hard to solve. I guess they could put an x cubed, and then you have to use your factor theorem from chapter 1 to do it. But I've never seen them do that much connections. But most of the questions, and we'll do example 1. Most of the questions are actually really easy. None of these have square roots. F of x is a line, And g of x is a parabola. And if you threw something into a line machine that got thrown into a parabola machine, what shape would come up? Good. I wanted you to have no idea. You should. So like, I don't know, right? It's kind of hard to think. If you threw a line into a parabola machine, what would come out? I'm not sure. We're going to find out. But what we can do is we can find the explicit equation first. And if you have the explicit equation, it's going to be super easy to A, state the domain and range, B, sketch the graph. Oh, it says state the domain and range of each function, so I'm going to just do a quick little graph of each one here. Can you see that your line, x plus 1, would look like this? It would have a domain of everything and a range of everything. And a parabola, 4 minus x squared, is x squared upside down, moved up 4 units. Its domain is everything, and its range is y is less than or equal to 4. For the composite function, we are going to find the explicit equation. So f of g of x means first you plug into g of x, which would give us f of 4 minus x squared. Then that 4 minus x squared gets plugged into f. What does f do? Whatever you plug into f, you just add 1. So you'd have 4 minus x squared, and then you'd add 1. If I simplify that, you see that you would get a negative x squared plus 5. Is that something that we can easily graph as transformations? Yes. Negative x squared plus 5. Technically, you'd have to label 2 points not to get an E9 error for graphing and not labeling E9. So I've labeled 2 points there. From this graph, can you see that it's easy to see that the domain is everything? And the range is less than or equal to 5. Same thing for B. Y equals f of x. Well, what does f of x do? F of x is just x plus 1. And what would happen if you plugged x plus 1 into f? Whatever you plug in, I plug in an x plus 1, then I have to add 1. So that'll just become x plus 2. And we have a straight line. Domain, everything. Range. So if we get the explicit equation, it'll be really easy to answer all of the other questions that come from it. If we just try to work with the original equations, it's not obvious what is going to result. Circle question number 4.